Let's continue to our second rule. Our first rule is Aufbau principle, which says start the lowest energy level. Our second rule to place the electrons is called Pauli exclusion principle. It is Pauli exclusion principle. According to this principle, you can put 2 electrons in an orbital, maximum 2 electrons in one orbital. This is called Pauli exclusion principle. Okay, and our third rule is Hund's rule. Hund's rule says if one electron is spinning this way, the other electron should spin opposite way, okay, to balance their motion. So according to Hund's rule, if one electron is going this direction, the other should go to other direction, that is to spin, to balance their motion. Let's go, and first principle, start from the lowest energy level. Second principle, only put 2 electrons in one orbital, and these electrons should point to different directions. So we have 3 rules to place the electrons in orbitals. Now what I am going to show you is, remember, for each energy level we have different orbitals. We have first energy level, we have s orbital. You see, first energy level, let's go back here. Here we have first energy level. I want to use this. We have one orbital here. We have second energy level. Look at how many orbitals you have when it is second energy level. Let's use blue. Second energy level, you have 1. You see how they start to second energy level. For the third energy level, remember, 1, 2, 3. And all these are making different directions, right? So let me draw you something here. If it is S-shaped orbital, it is make a spherical shape. This is S orbital. And for this one, we are gonna make one box. If it is P orbital, remember P orbital, it is making X direction, Y direction, and Z direction, which means this is X, this is Y, this is Z, which makes it can make a spin like this. This is called px orbital. It can make a spin like this in y direction. This is called py orbital. Or it can make a spin like this, back and forth. And this is called pz orbital. So for each p orbitals, if I say p orbitals, I am talking about 3 different locations. That is why I am going to make 3 boxes here. For d orbitals, this is hard to draw. I don't have many places. Let's try. For d orbitals, this is, maybe I should use an image. Okay, it can make 5 different shapes. It can make 5 different shapes. So let's make our coordinates here: x direction, y direction, and z direction. Okay. So it can make py direction, like it can make this. I am going to say this is pxy orbital, going this like, okay. It can go xz direction, make an x and go like z, x. This is called dxz orbital. Let's think. It can go yz direction, like this. Go y direction, go z direction. Y direction, z direction. This is called dyz orbital. What else it can go? It can go in between. It can go in between, like between x, like between x and between y and z. Oh, what happened here? Between y and z. So this is called dx squared y squared direction. Oh my god, Dr. I, what are you talking about? One more, guys. And it can make this shape. Up and down circle. Up and down circle. And this is called dz square direction. Look, you have 1, 2, 3, 4, 5 different motion. And you are going to make 5 different boxes for d orbitals. Again, z orbital, s orbital, s orbital, only one shape, so spherical shape. It makes one box. P orbital, 3 different shape, like this, okay, like this, 3 different boxes. D orbitals, 5 different shapes, like going this way, making zx, zy, in between. This is 5 different orbitals, okay? And we are going to put the electrons in these boxes 2 at a time, opposite direction. I'm gonna show one more thing in the next video.